Hi everyone, Miss Colasso here. So in this video, I'm going to show you how to solve Hardy-Weinberg problems. So the first thing you want to focus on is our two main equations. So that is P plus Q equals 1 and P squared plus 2PQ plus Q squared equals 1. So these are the equations that we're going to be working with to solve these problems. So now I'm going to break down each variable for you. So let's start with P. So P by itself is the frequency of dominant allele. So to help us understand this a little bit more, I'm just going to assign letters because that's how we've been seeing it before for genotype. So let's just say the dominant allele here is an uppercase B. Okay? So next we're going to be looking at Q. So Q by itself will then be the frequency of the recessive allele. So if the dominant is uppercase B, we know that this is going to be the lowercase b. So that is the frequency of each allele in the population. So now we're going to go to our main equation here. So we have P squared. Now this is going to represent the frequency of the homozygous dominant genotype. So that would be our uppercase B, uppercase B. Okay? Now we're going to move to our 2PQ. So this is going to be the frequency of the heterozygous genotype. So we know that because it has both P and Q, which as we saw here was our dominant and recessive. So this would be our uppercase B, lowercase b, if we're going to assign it letters. Now our Q squared then is going to be the frequency of the homozygous recessive genotype. This would be lowercase b, lowercase b. So the reason I want to show you this first is because some problems are going to ask you for the frequency of the homozygous dominant genotype. Some are going to ask for the recessive, heterozygous, the alleles. So I want you to be prepared to know what each variable stands for, okay? So that's our variable breakdown. Now we're going to go into solving problems. So I'm going to give an example that was actually from one of the practices in Apex. So in this problem, the population consisted of 100 individuals and 30 individuals of that population had the recessive trait. So let's say the recessive trait here was blue eyes. Okay? So the very first thing that we want to solve for is this Q squared. Okay? In any problem, you always want to solve for Q squared first. So right away we know the recessive genotype, right? So Q squared, is going to be 30 individuals divided by 100 because it is the frequency of that recessive genotype in the population. So we're going to do 30 divided by 100, and that's going to give us 0.30. So now we know that Q squared equals 0.30. Now what we're going to do with this information is we want to take the square root and just find Q by itself. So we know that Q, and I'm going to do this in my calculator, so Q is going to equal 0.548. So something that's really key for these problems is that you always want to make sure that you're rounding to at least the third decimal point and not making it too short, okay, because we want to make sure that we have all of the accurate calculations. So this gives us Q. So now for this problem, we have the recessive, but we want to find the dominant. So what we're going to do is we're going to find our P from using this equation. So if we go here, we have that P plus Q equals 1, right? So we're looking for P, so I'm gonna do that over here in red so we can see. Let's plug in our Q value. So P plus 0.548 equals 1. So now just doing some math, right? We're gonna subtract that Q value over by 1. So P is then going to equal 0.452. So now if the problem is asking the frequency of the dominant allele, you know that P equals 0.452. Now all we're going to do to now find the frequency of the homozygous dominant genotype, right, we're just going to square this. So P squared equals 0.452 squared. P squared equals, and I do this in my calculator, and it is 0.204. So now we have our Q squared, our Q, our P squared. Now the last thing I want us to solve for is this 2PQ. Because if the question asks for the frequency of the heterozygous genotype, we need this 2PQ value. So let's plug in for this equation now. So we have our P squared value, so P squared plus, and I'm just using different colors to kind of help us see the difference. 2PQ plus Q squared equals 1. So now we could plug in the values that we got. So we have 0.204 plus, now we have 2 times our P. Now make sure we're just using the P, not the P squared. So now we have our 0.452 times Q, remember just the Q value, so we want to use this one right here. Q equals 548, okay? And then we could add our last Q squared. So now we go back to our Q squared. The original value we got, 0.30. And this should all equal 1. Okay, so we could take this 2PQ value out right away, do this math in our calculator, and we are going to get 0.495. So that would be our 2PQ, the heterozygous genotype, okay? And then we already have this, so if you want to check your math, you could solve this equation. So 0.204 plus 2 times 0.452 times 0.548 plus 0.3, and that should give you 1. So that's how you can check your work to make sure you got all the right values. Okay, so just to review, we have our P value we need to solve for, our Q, P squared, 2PQ, and Q squared. And just knowing these variables, this will really help you solve all of these problems. Okay, everyone, I hope this helped. Bye.